The objective of this video is to help you write algebraic expressions for section 1-4. And so on this homework that I assigned, I'm simply going to be focusing on the larger word problems, not the little ones. So before we start, the first question you're going to want to be asking yourself is the variable defined? Sometimes it's yes, sometimes it's no. And oftentimes when it's defined, they'll look like this. They'll say there's M months, T TVs, H hours, B bats. And what they're telling you is the B is for bats, number of bats. H is for number of hours. T could be for number of TVs. M. So they're defining the variable. They're telling you that there's actually a B, meaning number of bats. Whereas when they don't define it, then you have to define it. And you might say, okay, the word problem is wanting to know the number of axes. And so you might say A. Let A represent the number of axes. And so you would have to designate it. And you could choose just about any letter you want. Just make it lowercase. So as we do this, ask yourself that question. And I'll keep coming back to it. Some of the common ones we run into are that throw kids off is a question like total cost. They might ask you to write an algebraic expression for total cost, and maybe it is $25 a month. And they're saying, they might say, what's the total cost for many months? And you're like, okay, well, how do I write an algebraic expression for this? Well, let's think about this. First of all, do we know the number of months? No. So we would want to say, well, M is the number of months. Now I'm writing quickly here, but that's not hashtag, that is number of months. So we know now, and we just defined M. And so what we know is that for 1 month, right, it's $25. For 2 months, it's $50. For 3 months, it's $75. We could go on forever, but we don't know how many months, right? And we want to write an algebraic expression for the total cost for unknown months. Well, we know it's $25 a month, and if we multiply that by the number, or the unknown number, M, that would express the total cost. Now, do you see how we set this up? Let me try one more. How about, let's do another total cost. And let's say you pay 36 cents a minute, right? 36 cents a minute to ride the pony. Okay? Now, first of all, I want you to write an algebraic expression that expresses the cost for all the minutes you rode the pony. Well, do we know how many minutes? No. In fact, that's that we don't know that. So that's going to be our variable. M equals number of minutes. We don't know. But what we do know is this. That 1 minute is what? 36 cents. And 2 minutes is what? 72 cents. And 3 minutes is what? $1.08. Right? But, and we got that by multiplying the number of minutes times the cost, and we could find total cost if we multiply the number of minutes times the cost of 1 unit, which was 36 cents. But since we don't know, what we could express it as 0.36 or 36 cents times M, which is the unknown number. This would express total cost. All right, so that's a common expression that I see that kids struggle with, and I wanted to just kind of preemptive try to work on that. Let's start. And you might want to have your little expression sheet or word phrases to math symbol sheet. Okay, that might help. I'm at 4 minutes and 36 seconds, so let's get started. I'm going to be covering up, there we go, number 5. And so if you already did this, watch it, think it through, and check your work. Make sure you're on the right pathway. Carly spends $5 for in notebooks. Did they just define the variable? Yeah. We have how many notebooks? In notebooks. What quantity? It's unknown. Write an algebraic expression to represent the cost of one notebook. So we know that all the notebooks cost $5, and if we divide that by n, that unknown quantity, we're going to find out how much it is per one. So it's 5 divided by n. Let's look at the next one. Here we have a company charges $46 for a cable TV installation and $21 per month. There's that term. For basic cable service. Write an algebraic expression to represent the total cost of m months. So they just defined the variable of a basic cable service including installation. So we have this one-time fee of $46. And then we have the word and. What does that translate into? Let's take a look at our little phrase sheet and look at that. And implies addition. All right. So we have $46 and $21 per month. Now, do we know how many months? No, but we know m represents the number. So this expresses the cost for its initial setup fee and $21 for however months you have that cable service for. And to be honest with you, you don't want cable, so we could just put a 0 there. But this would capture that. There it is. Got it right. Let's go to this one. Video Express sells used tapes. Marta bought V tapes. Did they just define the variable? Yeah, V tapes. How many tapes? V tapes for $45. Write an expression for the average cost of each tape. So we have $45, and if we divide that by V tapes, the number, we're going to find out how much each one is. So, yep, got that one right. Please don't write it that way. Write it this way. All right, let's move to the next one. A 5-foot tree was planted and grew 2 feet each year. Write an algebraic expression for the height of the tree after t years. So we know it's 5 feet. And it grew what? So that and tells us we're adding 2 feet each year. Well, do we know how many years it's growing for? No. But we do have a variable that represents that number, and it's t, because it's for t years. So we're going to use a t here. So let's just think about this. So in 1 year, it would be 5 plus 2 times 1. In 2 years, it would be 5 plus 2 times 2, because that's 2 years, and then so forth. But because we don't know how many years, that t represents it. Let's move to the next one. Let's move down here to the bottom. An ice cream machine, an ice machine can produce 17 pounds of ice in 1 year. No, 1 hour. Write an algebraic expression to describe the number of pounds of ice produced in hours. Well, we know it can produce 17 pounds in 1 hour. So in 1 hour, we get 17 pounds. In 2 hours, we get 34. In 3, we're going to get what? 51. And I could go on forever, but we want it for how many hours? In hours, we don't know, but we know that if we multiply the number of hours times 17, we find our total. But we don't know what it is, but we know we have a variable to represent it, which is n, so it would be 17n. All right, look at B. B's a little different. How many pounds of ice cream can a machine produce in 4 hours? Well, okay, so we know in 1 hour it's 17. And this time it's not just an unknown. We actually know in 4 hours, so we can actually multiply it times 4. And we can actually solve this one because there is no variable actually. So it's 68. Let's try this one down here. How am I in time? Oh, I'm doing pretty good. I got 5 minutes. Karen earns $65,000 a year as an optometrist. She receives bonus of B dollars. Wow, they just defined my variable. B stands for dollars. a bonus of B dollars last year and expects to get double that amount as a bonus this year. Write an algebraic expression to show the total amount Karen expects to earn this year. All right, so let's write our expression. We know in 1 year she makes $65,000. But now let's read it carefully. She receives a bonus of B dollars. So we would add that. We have a B here for her bonus. But let's keep reading. And last year, and expects to get double that amount this year. So how do we express double B dollars? Well, that would be 2B. So $65,000 plus 2B, or 2 bonuses. Yeah, there we go. Let's move on to the next page. This one I find a little disturbing because it's about these little mites living in our eyebrows. Now, if I was a monkey, that makes sense, but I'm not a monkey. Let's take a look at life science. The tiny and harmless follicle mites live in our eyebrows and eyelashes. There it is right there. They are relatives of the spider, and like spiders, they have 8 legs. Let's think about that for a minute. So one spider has 1, 2, 3, 4, 5, 6, 7, 8. 2 spiders have 9, 10, 11, 12, 13, 14, 15, 16. Another spider has, and you see what I'm getting at? Now, all right, let's keep going. They are relatives of spiders, and like spiders, they have 8 legs. Write an algebraic expression for the number of legs in M mites. Did they define the variable here? Yeah. How many mites do we have? I don't know, but we have M mites. That represents the quantity. Well, if each mite has 8 legs, and we know one mite has 8, and if we have 2 mites, we get to 16 legs, and if we have 3 mites, we get to 24, and it goes on and on and on. But since I don't know how many mites, I'm going to multiply 8 times M, which represents the number, or 8M. Where are we at? Okay. Let's position this as a little bit better. Here we go. Write an algebraic expression for the number of grams of carbohydrates in Y pieces of fruit and 1 cup of milk. All right, well, here's our fruit. How many grams are there? There's 15 grams in 1, but we have Y pieces, so that would be 15 times Y, and that means plus 1 cup of skim milk. Well, 1 cup has what? 12 grams, and that would be that expression. Can I solve that? No, because I have a variable. Cannot be simplified. Let's try this one. Let's just pretend. Let's see here. How many grams of carbohydrates are there in a sandwich made from T ounces of lean meat? So here's my lean meat. How many ounces are there? 0. So that would be 0 times T plus, so how many ounces is there in that meat? And 2 slices of bread. There's my bread. I have 2 of those, so that's 15 times 2. Well, what's 0 times anything? 0. So that cancels out, and all we're left with is this, 15 times 2, which is 30 grams. That's why it says 30 grams. I have 1 minute left. I'm going to let you guys work on those. Guys, as you work through this, remember to ask yourself, is the variable being defined? And if so, what is it? How can I use that to craft my algebraic expression? Sometimes it helps to use your words and phrases to math symbols. But in the end, you want to identify what is my variable and how can I use that with my operations to write an expression to capture what's happening in these word problems. When we come back, we're actually going to apply it to more word problems. And what's going to come next is we're going to be taking an expression like t plus 8, and it's no longer going to be an expression, but it'll be set equal to a number. And once we get to this point, it becomes an equation. See that equal sign? And we have an expression equal to an expression, and when you have that, you can actually then find the value of your unknown. See you on Thursday.